Hello everyone. Um, our name is JASIT and my name is Hanato.
My name is Hood.
My name is Rintaro.
My name is Sosuke.
My name is Taisei.
And then Australia team is Aisha, Bodhi and Pasi. Next. First, I have a quick question. Do you know space debris? The space the term space debris may not be familiar, but in reality, they were over 100 million pieces orbiting the Earth at the, at the speed of 7.8 km per second. They do not stop naturally, and most are artificial object created by us humans. So we as humans must take responsibility and address this problem. Next. Australia team, please.
Australian team is now okay to present.
Next slide, please. Hello, we are the Australian team. I'm Alyssa, this is Bodhi, and this is Patsy. Since the beginning of the year, our team has thought of a problem, researched solutions, and become friends with all of our team members. The idea our team came up with was the collection and deorbiting of space debris. Next slide, please. Our team wanted to come up with a solution to space debris that is slowly stopping humans from accessing space. Essentially, our team has created a solution to avoid Kessler syndrome from occurring. Kessler syndrome is when the density of debris becomes too high and constant collisions between objects occur, creating more smaller debris. The collision of space debris can also affect existing satellites and systems that are essential for humans. Next slide, please.
Tracking space debris, our first step on the progress of removing space debris is to track the location of debris from our orbit, and there are two methods in tracking that can be used. They are LiDAR and haystack pottery. Next slide, please. The haystack auxiliary radar will be used to collect data on the space debris. It will transmit what information it has gathered to the US Space Surveillance Network, which is a network of grounded space-based radar and optical sensors that track and catalog artificial objects in Earth's orbit. Next slide, please. LiDAR tracks space debris by emitting a pulsed laser of light, measuring the time taken for the light to reach the intended object, reflect off of it, and return to the sensor. This system will be implemented and used on the spacecraft, with the information being sent back to an operational base on Earth. Information regarding the debris' shape, size, trajectory, and position will be gained from using LiDAR. This means that when we send objects into space, it will be easier to avoid a collision, and the collection of these materials will be made a lot easier as well. Next slide, please. Inflatable spacecrafts have risen in popularity for several reasons. The price of these stations is significantly less than regular ones due to its lower mass, with mass being a factor when considering the cost of launch. They are also less affected by contact with space debris, bouncing the foreign material away. They are also bouncing the foreign material away without deterring it from its course. Using a station that rebounds debris away from itself is ideal due to the mass amount of pollution in Earth's orbit. Next slide, please. Lasers. Lasers are a tool and another method of collecting debris, but does not completely destroy the debris. The idea of using lasers is to target and break down large debris into smaller pieces for it to be able to capture by the nets easily. Our idea is to use this specific type of laser called space-based lasers. Space-based lasers worked by using nuclear reactions that release high-energy charged particles called fusion fragments. The fusion fragments collide with gas atoms, creating an inverted population of electrons in gas energy and emit laser light that creates a concentrated beam. Next slide, please.
Japanese team is developing a way to space debris without destroying it. So it can be captured with a net. They use a ground use a pulse laser to create laser ablation. Usually, heating debris surface. They use the gas and plasma and the equal graduation changes its orbit. Three. And we use UV-coated polyester and Kevlar fiber and air gel and CFLP and MLI to make catch nets. And this is the structure of the nets. And this part of net is Kevlar fiber and UV-coated polyester. The Kevlar fiber is Kevlar fiber is to expand, capture the debris and expand the coverage area. And UV-coated polyester is to protect Kevlar fibers from UV exposure. And this structural part is CFLP and MLI. CFLP is to act as structural frameworks, and MLI is to protect the CFLP from heat. And this part is made of air gel and Kevlar solid composites, and they are to absorb impacts from space debris. And to make such nets, we estimated that 7,780 kilograms of Kevlar air gel and 1,362 kilograms of Kevlar solid composite would be required. And these are estimated costs.
Did you land in the right spot? Well, you know that.
However, Kepler in the net cannot withstand temperatures above 480 degrees Celsius. So it could tear if too hot. Using a ground-based pulse laser to slow the debris prevents this damage. These formulas from left to right are used to calculate velocity, total energy, and time.
Using the formula we introduced earlier, we calculated that to capture a 10 centimeter piece of debris at a speed of 2 kilometers per second. Ground-based laser must deliver 21.8 megajoules over 22 seconds. The cost is too high for a single company. In other words, solving this problem requires global cooperation.
And finally, our research showed that burning space debris in the atmosphere is less costly than recycling. So we are talking about recycling. No, burning space debris. Recovered debris can be controlled to re-enter at about 25,000 kilometers per hour and burn up, or if not completely, fall safely into the ocean. This is the end of our presentation. Thank you
for listening.
Thank you.